Our next lesson is called function notation. So we're going to start with a little activity to introduce you to this type of notation. First, I'm going to write an equation and it's going to look strange. Okay, so there's the equation I'm writing and it should look strange to you. This is not something that you've seen before. So now I'm going to change a few things and I want you to think about what are the changes. So take a second and pause and think, what's the change that you see between what I did first and what I did second? Hopefully you see that instead of an X, I drew a heart. So I replaced the X with a heart in every single place that you saw an X to begin with. So here's my next question. Now what's the difference between these? Looking at those two equations, what's the difference between them? Think for a second. Hopefully you see that this time I replaced all the X's with an A. So it's an A instead of an X. Okay, and what about these? Think about it for a second. What's the difference between these two equations? Hopefully, again, you saw that I replaced all the X's with a 3. So it's now a 3 instead of an X. Okay, here's another puzzle that I want you to look at. So can you figure out what this notation means? So I want you to pause the video for this one, take a look at the puzzle, and see if you can figure out what this notation means. Okay, now that you've had a time to look at that other puzzle, I kind of labeled on the graph what the puzzle was showing you. F of negative 2 equals 4. So again, X is being replaced with a negative 2. And I hoped you would see that in the graph, the number that's in the parentheses is the X. The answer is actually your Y value. So when I say F of negative 2 equals 4, I found the X value of negative 2, and I looked to see what the Y value was. It was 4. F of 0, I looked to see what Y is when X is 0. F of negative 1, the X is negative 1, so I go to negative 1, see what the Y is, it's 3.5. And then the same thing for F of 2. I find the X value or input of 2 to find out what the Y value is, which is negative 1. So we're going to write on the side here that the number in parentheses is the X. The answer is the Y value. So if I go back up and look at our last example here where we had F of X equals 2X squared plus X minus 1 and F of 3 equals 2 times negative 3 in parentheses plus 3 minus 1, I can see that since X was replaced with 3 went into all the places that X was. And now if I actually wanted to complete it like we did similar in the puzzle, I would do 2 times 3 squared is 9. And then 2 times 9 is 18. 18 plus 3 would be 21 minus 1 would be 20. So here I would write that F of 3 equals 20. And it has a similar notation to the puzzle you just did with the graph next to it. Mathematicians often work with more than one function at a time, so it's helpful to have a way to give a function a name. In function notation, the most popular letter to use is F for function, but just about any letter can be used to name a function. Let's look at how the function y equals 2x will look if we write it in function notation. So instead of writing the y, we'll call it function f, And the way we would write it is the f in parentheses the x and then equals 2x. So all I did was replace the y with the f parenthesis x notation, which is pronounced as f of x. The letter f is the name of the function. The x is written in parentheses to tell you that the variable for the input values is x. It's very important to notate it does not mean f times x. It is not multiplication. So moving on to the next page, we have some more notation diagrams to help you with this new notation you're learning today. So again, f would be the name of the function. Whatever's in the parentheses tells you that x is the input or whatever is the input. And what you see on the other side of the equal sign tells you what the function does. So in this case, the function is multiplying the input values by 2 because 2x. So over on the side, you can see a table of some more examples. Written as an equation, it would be y equals 5x. Written in function notation, it would be f of x equals 5x. Y equals x plus 7. G of x equals x plus 7. So also showing you that you can switch up the letter that you call the function. Y equals x squared. H of x equals x squared. So the only thing we are doing is we are taking the y and we are replacing it with this new notation, f of x, g of x, or h of x. So the function name and then whatever the input is. So in the paragraph it says, in the examples above, we use the letters f, g, and h to name the 3 different functions. These are the most common letters used to name functions, but really about any letter can be used to name a function. Notice that all 3 examples use the variable x as the input variable. While x is probably the most common variable you'll use in algebra, it doesn't always have to be an x. And if you think back to our opening exercise, I used an heart and I used the letter a. So if you look at the table on the right, you can see several different ways to write the same function using different variables. So the most traditional, again, is going to be your first one, f of x, and you can see x has been replaced in all of it. Here, f of t, the t's have gone in x's spot. Here in a, the a has gone into all those spots. And I even showed you an example with another shape. Here's a star. So what goes into the function is put inside the parentheses after the name of the function. So f of x shows you the function is called f and x goes in. So an example with f of x equals x squared. If the input x is 4, then the output of the function would be 16. In fact, we would write f of 4 equals 16. Now that's coming from f of 4, meaning that we're going to replace the x with a 4. And then 4 squared is indeed 16. So f of 4 is 16. That's where that's coming from. So let's look at example 2. The function g is defined as g of x equals 2x plus 3. So what is the value of g of 5? Negative 5. So that means that negative 5 is our input. So I'm going to say g of negative 5 equals, and every place where I see an x, I'm going to replace it with negative 5. Then I can go ahead and actually simplify that like we did earlier. 2 times negative 5 is negative 10. Then I need to do negative 10 plus 3. So that means g of negative 5 is equal to negative 7. Now this also works on graphs. So the graph of the function f is shown. We're going to find the following. So in example A, f of 0 means we have an input of 0, which remember input means that took x's spot. So x equals 0. I need to find f of x, or what we traditionally know as y. So I'm going to go over to my graph, find an x value of 0, and see what my y value is. At that point, when the x value is 0, the y value is 1. So that means f of 0 equals 1. If I do f of 1, that means I have an input of 1, which means my x value is a 1, which means I need to find f of x, or what we traditionally know as y. So I'm going to find my x value of 1, which is right here. I'm going to find out what the y value is at that time. It is a 3. So this is f of 1, which means that f of 1 is equal to 3. So now I'm going to have you try some of this with your new notation in the practice section. I'd like you to pause the video and try questions 1 through 4. Then when you're ready to check your answers, you can resume the video. Okay, now that you've had a chance to try the practice questions on your own, let's go over the answers. For number 1, the function f is defined on the real numbers by f of x equals 2 plus x minus x squared. What is the value of f of negative 3? So you can see that I wrote f of negative 3, and everywhere where the function originally had an x, I have swapped out the x with a negative 3, making sure that I use parentheses. Then I followed order of operations. Parentheses first, then exponents. We had exponents. Negative 3 in parentheses squared is a positive 9. So this part is replaced with a positive 9. This is the negative from the original function equation. So then I went through and did my addition and subtraction and got negative 10. So that means f of negative 3 equals negative 10. For number 2, g of x was x squared plus 1 in parentheses times 3x minus 5 in parentheses. What is the value of g of 4? So again, wherever there was an x, I replaced it with a 4. I again followed my order of operations and worked inside the parentheses first. Within the parentheses, I made sure to follow the order of operations. So 4 squared, in the second set of parentheses, that would be 3 times 4. Then I simplified using my addition or subtraction, and then did multiplication as my last step. So g of 4 actually equals 119. In number 3, complete the input-output table for the given function. F of x equals 3x plus 7. So in this notation, the x side was filled in, so it's giving me all my different inputs. I'm doing my substitutions over here on the side, so you can see f of negative 5, every place there was an x, I replaced it with negative 5. F of negative 2, everywhere there was an x, I replaced it with negative 2, and so on. I then simplified using the order of operations to get the values negative 8, 1, 7, 10, and 16. And in number 4, I graphed the function g of x equals negative 2x plus 1. Think about y equals negative 2x plus 1. I'm going to graph it the same way. So my slope was negative 2, so I wrote my slope down as my work, negative 2 over 1, which means I'm going down 2 to the right 1. And then my b value or y-intercept is a 1. So I started on the y-intercept by graphing 0, 1, and then I went down to the right 1 in order to graph my line. I continued to use arrows, connect, and I labeled it with g of x equals negative 2x plus 1. So when it comes time to find g of 2, that means my input is 2. Input would be my x value, so x equals 2. We have to find g of x or y. So I go to the graph and I find where x equals 2. I follow it down and over to see what my y value is. My y value is a negative 3. So that means g of 2 equals negative 3. And that concludes your lesson on function notation.